Today we're going to find the derivatives from graphs. So first, let's just go over a few characteristics. So f of x, that is going to be the point on the graph. Okay, so if I ask for f of some number, your answer is going to be the y value at that point. Okay. If I ask for f prime, remember this little prime symbol means derivative. Okay. F prime is going to be the slope of the graph. So your answer there is going to be the slope at that specific x value. Okay. Now there's a few times where we can't take the derivative or can't find the derivative of the graph. So a graph is not differentiable anywhere there's a sharp point in the graph. Okay, that means there is no derivative. And then the slope of the graph is 0 at the vertex of a parabola. So let's look at a few examples to talk about what all this means. Okay, so use the graph below to answer the following questions. So we're given the graph of f of x, that's the graph in red, and then the graph of g of x, which is the graph in blue. So at which points is f of x not differentiable? So remember, it's not differentiable anywhere you have a sharp point. Okay, not rounded. So if I look at f of x, this red graph, there's a sharp point at -2. Okay, so it's not differentiable at x equals -2. And then again, there's a sharp point here at +2. And then at 3, this is rounded, so that doesn't count as not being differentiable. It has to be like a corner, not a rounded part. So f of x is not differentiable at x equals -2 and +2. So if I look at g of x, at which point is g of x not differentiable? The only place I have a sharp turn in g of x is at 1. So that's just going to be x equals 1. Okay. So anywhere it's not differentiable is anywhere you have like a corner, a sharp point on the graph. Okay. Now to evaluate these. Okay. For f of 3, this is just the point. So I'm going to go to 3. I'm going to go up to the graph. This point right here is x is 3, y is 2. So my answer is just 2. Okay, when it's just f of 3, our answer is always going to be the y value. Okay, when it's prime, our answer is always going to be the slope. So if I look at 3, that is the vertex of a parabola. Okay, and at the vertex of a parabola, the slope is always 0. Okay, so our slope is always 0. At the vertex of any parabola. Okay. So now for part C, if I look at f of -1, I'm going to go over to -1, I'm going to go down to f of x. Okay, this y value right here is also -1. Okay, then if I want the slope here, okay, remember slope is going to be rise over run. So on this line right here, so I'm just looking at this horizontal section, okay? So the slope of this horizontal line, that's just going to be 0. Remember, the slope of a horizontal line is 0. Slope of a vertical line would be undefined, but we're not going to have any vertical lines. So the slope of any horizontal line is 0. So if I wanted to count my rise over run, I'm just going to look at this entire section of the line. Okay, so if I counted my rise, that's up 0 over 4, that would give me a slope of 0. 0 over anything is going to be 0. Now if we look at g of 3, okay, so now I want to go to 3 on the x-axis, and I want to look at the graph of g of x, which is this blue one. Okay, so this point right here, the y value is 0. Okay, so g of -3 is just going to equal 0. Then for g prime, so this is the slope at -3. So I just need to find the slope of this line. And I can use any 2 points on it. I'm just going to start here and go to this point I've already marked. So my slope, that is down 2. So that's going to make my rise -2. So down 2, right 2. So my rise is -2, my run is +2. That's going to make my slope -1. So you can pick any 2 set of points on this line that 3 lies on. Okay, so 3 is on this section of the graph, so I could even count down 1, right 1. That would give me a slope of -1. If I picked the starting point to this last point here, that would be down 3, right 3, so -3/3. No matter which points I pick, I'm going to get a slope of -1 at this section of the graph. Now if we look at g of 0, so that's this point right here. So g of 0, that y value is 1. Okay. Then if I want the slope, same thing. I can just pick any 2 points on this section of the graph because this is a line. So everything is going to have the same slope on this section of the graph. So if I count from here to here, my rise over run, that is up 1 over 1. So I would have up 1, right 1 to give me a slope of 1. Now I left 2 examples off of here, so let me go ahead and add f of -4. And then we're going to do f prime of -4. And these will be the last 2 that we do. So now for f of -4, I'm going to go over here, okay, go up to the graph of f, okay, and then I'm going to look at my y value. So f of -4, our y value is 3. Okay. Now for f prime of -4, we want the slope. Okay, so I'm going to count the slope of this line. So I'm just going to use these 2 points right here. Okay, so even though they're talking about the slope of -4, to get the slope, you always need 2 points on this line. So if I count my slope here, that is down 2. So my rise is going to be -2, and then my run is going to be right 1. So the slope at -4 is -2. Okay. So anytime they just ask for g of a number or f of a number, you're just looking at the y value of the point. Anytime they're asking for f prime or g prime, you're looking for the slope of the line that that point is on. Okay. And then again, the only time I'd ask you for the slope where it isn't linear would be at the vertex of a parabola. So I wouldn't ask you for the slope on either of these curved sections of the graph. I will only ask for f prime or g prime where the graph is a line. Okay. So now you'll have a formative, and it'll be due at the end of the period.